everyone, welcome to Success Plus YouTube channel. Today we are discussing about Johnson's counter. Before going to start our explanation, let's see what is Johnson's counter. A Johnson counter is a modified ring counter in which the output from the last flip-flop is inverted and feedback as an input to the first. It is called as inverse feedback counter or twisted ring counter. These ring counter are used in the hardware logic design as found. Let's example within ASIC and FPGA ICs to create complicated finite states machine. Johnson counter circulate a stream of ones followed by zeros around the ring. For example, in 4 registers counter with initial register values of 000, repeating the pattern like 1 triple 0, 1 1 double 0, triple 1 0 and 1 1 1. Then 0 triple 1, 0 0 1 1, 0 0 1, 0 0 0, and it is repeated, right? See, to find out this unused state, the Johnson counter can be implemented using n flip-flop to count 2n distinct states. A features that make it better than ring counter that use an equal number of flip-flops as it serves twice the number of state. This counter is used in application where the number of state is higher than the number of flip-flops. As you can see here, to find out the total number of used and unused state in the Johnson's n-bit counter, 2n is the number of used state. Finding of unused state, we have the expression like number of unused state equal to 2 to the power n minus 2 into n. Let's take an example of this Johnson's counter. If we consider a 4-bit of Johnson's counter, okay. Suppose all the flip-flops are in state, means they are in 000 forms. Okay. This is the block diagram of 4-bit Johnson's counter. Here the clock pulse is applied simultaneously. Q1, Q2, Q3, Q4 are the 4 states. Here we taken a day flip-flop. Okay. Here how to determine the total number of used and unused state in 4-bit Johnson counter. Let's see the answer. Okay, as we can know, 2 into n, number of used state, that is equal to 2 into 4, 8. To find the unused state, that is equal to 2n minus 2 into n. 2 into n, that is equal to 8. Right? 2 to the power 4 minus 2 to the power 2 into 4, that is equal to 8. Bits are unused states. Likely we can see the truth table of this Johnson counter of 4 bits. 4 bits means Q1, Q2, Q3, Q4 are the states. Initially the clock is 000. Then we apply the first cycle of the clock is 1 0 0 0. That last bit of Q4 is 0 and inverted as 0 to 1. That 1 is feedback is to the first flip-flop then the 1 is passed to the first flip-flop to Q1 is 1. Then the previous value which is hold in Q1 is shifted to the Q2, and the previous hold Q2 value is shifted to the Q3. Similarly, Q3 hold value previous, that is shifted to the Q4. Then the Q4 is 0, then inverted 0 to 1. Then the 1 is passed to the again Q1. Then Q1 is 1. Then Q1 previous state is 1 is shifted to the Q2. Then the previous state of Q2 1 is hold, that is shifted to the Q3. Similarly, Q3 is holding the value, previous value is 0, and shifted to the Q4. Then again is shifted, Q4 is 0, inverted as 1. Then 1 is shifted to the again back to the pass to the Q1. Then previous value of Q1 is shifted to the Q2, and Q2 previous value is hold as 1 shifted to the Q3, and Q3 is shifted to the Q1 which is previous value. Then Q4 is 1, and 1 is complement is 1 is 0, then 0 is passed to the Q1, that is 0. The previous value which is hold Q1 is 1, that is shifted to the Q2. Similarly, Q3 is 1, Q4 is 1, previous values of Q3 shifted to the shifting 1 by 1. Similarly, the last we get 0, 0, 0, 0 states. After this completion, and the cycle is repeated. Right? In this way, how the Johnson's counter can work. Let's see the Johnson's counter, advantages of Johnson's counter. Here we have few advantages of Johnson's counter are: Johnson's counter has same number of flip-flops, but it can count twice the number of as a ring counter. Ring counter can count the number of state is n state, where the Johnson's counter can count twice, that is 2n state, 2n. It can be implemented using D flip-flop. Johnson's counter is used to count the data in continuous loop. Next advantages is a self-decoding circuit. Johnson's counter is self-decoding circuit. Next, see the few disadvantages of Johnson's counter. Johnson's counter does not count the binary sequence. Next, in Johnson's counter, more number of states remain unutilized than the number of states being utilized, as we can saw with the help of this truth table. The number of flip-flops is needed is 1/2 of the time signal. Let's see the application of Johnson's counter. Johnson's counter as a synchronous decade counter. Decade means 10 or mod 10 counter. We can say as decade means 10. Or divider circuit. It is used in hardware application design to create complicated finite state machines like FPGA, ASIC design. These are the examples. Next advantages is three-phase. Johnson's counter is used as three-phase square wave generator which produce 1200 phase shifts. And last application is it is divide the frequency of the clock signal by varying their feedback. As you can see in the figure, we given the feedback, right? It is also used for divide the frequency.